Section 5 in Unit 9 is titled Scientific Notation. Scientific notation does deal with exponents, and later on when we get to multiplying and dividing numbers in scientific notation, we'll get to still apply the properties of exponents. So this is a little bit of a review, hopefully, but since it deals with exponents, it fits nicely in this unit. So, two definitions, standard form and scientific notation. So we'll be working today with changing numbers between scientific notation and standard form, and then back from standard form to scientific notation. But standard form are numbers that do not contain exponents, and scientific notation is a number that's expressed as a product of a factor and a power of 10. So please write this slide down, but this is scientific notation. Again, it's a number expressed when it's written as a product of a factor and a power of 10. The biggest rule with scientific notation is that the factor must be greater than or equal to 1. So this number out in front that we typically see in a decimal form needs to be greater than or equal to 1 and less than 10. So scientific notation, a times 10 to the n, again where a is greater than or equal to 1 and less than 10, and n is an integer. So in scientific notation we deal with positive and negative exponents in the scientific notation. So the first example, 3,500,000 is written as 3.5 times 10 to the 6th. You'll notice that the 3.5 is between 1 and 10. And let's see, that's tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. 400 thousandths is written as 4.0 times 10 to the negative 5th. We'll talk in a moment that large numbers that are greater than 1 have positive exponents. Small numbers that are less than 1 have negative exponents. And that has to do with which way you're moving the decimal when you're changing it to scientific notation. So first let's go from scientific notation to standard form. So the number is 2 times 10 to the 3rd. And I like to rewrite the digit so that I'm not like drawing within the number. I get confused. So here's 2, and the decimal point on the number 2 is behind it. If it's times 10 to the 3rd, we move the decimal place 3 times to the right. 1, 2, 3, and you fill in zeros. So 2 times 10 to the 3rd is 2,000. I like you then to also go over and rewrite the number so it looks a little nicer, putting in your commas where they go. Number 2, we have 6.8 times 10 to the negative 5th. So again, I'm going to rewrite 6.8. This time though, instead of moving the decimal to the right, because it's a negative 5, it means we're talking about a really small number, we're going to move the decimal to the left, and we're going to move it 5 times. 1, 2, 3, 4, 5. And again, you fill in zeros into these little dips here or places. And when you write a decimal, I do like you to put a leading 0 in front of the decimal place. So that would be out here, but it's 1, 2, 3, 4 zeros after the decimal. 68. So that would be tens, hundreds, thousands, 10 thousands, 100 thousands, millions. So we're all the way out in the millionths place. Number 3, 3.25 times 10 to the negative 4th. So again, 3.25, it's a negative exponent, which means we want to move it to the left 4 times, filling in 3 zeros after the decimal. So that's how you write a number from scientific notation into standard form. If you'd like to pause the video and try these 3 on your own, and then you can check your answer with me. So 4, we're going to move it twice. That's 400. 5.94, we're going to move it 7 times. It's 59,400,000. Please make sure that when you do this, you are again putting your commas in the right places. Remember, commas go every 3 digits, starting from the right-hand side and moving left. Number 6, again, we're moving to the left this time. We're talking about a very small number. 0.0013. So hopefully that was a review. Now let's go the other way. This should also be a review. But when you're putting a number in scientific notation, the only thing you have to make sure, the only thing you have to make sure of is that that digit that's the factor is between 1 and 10. So I like to kind of, in the beginning, figure out where I'm stopping my decimal. My decimal needs to stop here. Right now it's back here, but I need to stop it after the 4 because 4 is between 1 and 10. So now I just count how many times does it move. 1, 2, 3, 4, 5. It moves 6 times. So we write this as 4 times 10 to the 6th power. It's a positive 6 because 4 million is large. It's bigger than 1. 5,800. So we want the decimal to be here. That's 5.8. It is back here. So you move it 1, 2, 3 times. So that's 5.8. And if the last digits are all zeros, and I should have mentioned this in problem 7, if the last digits are all zeros, we don't have to write all those. So you don't have to say 5.800. You can just say 5.8. And again, we moved it 3 times, so it's times 10 to the 3rd. And it's a positive 3 because 5,800 is a larger number. Number 9, we're going to move the decimal to the right, and we want to stop it here at 7.2. So we're going to move it 2 times to the right. So the number becomes 7.2 times 10, but now we say the negative second because it was a small number, less than 1. Three more here if you'd like to, again, pause the video and see if you can compute some of these on your own. 900, we have the decimal in the back. We're going to move it 2 times to get 9 times 10 to the 2nd power. 18,900, it's in the back. We're going to move it 1, 2, 3, 4 times. 1.89 times 10 to the 4th. If you're struggling with where to stop the decimal, remember again, this number in the front has to be between 1 and 10, so I couldn't have stopped it between the 8 and the 9 because then it's 18.9. That's too big. Number 12, we're going to move it to the right 1, 2, 3, 4, 5 times. So that's 6.4 times 10 to the negative 5th. Remember again, a small decimal less than 1, we're moving it to the right. We have a negative exponent. Finally, we need to be able to compare numbers in scientific notation. So it says to order them from least to greatest. The first place you should check is the exponent. So obviously smaller exponents are smaller numbers. So the first number in this list is going to be the 6.64 times 10 to the 7th. Now everything else has an exponent of 8. So now we're just comparing the factors in the front. So next is 2.08 times 10 to the 8th. Followed by 2.45 times 10 to the 8th, followed by 4.48 times 10 to the 8th. In class, we will work on worksheet 9.5.